I'm going to talk about the data reduction pipeline. It's a presentation, and I will. I'm the product DRP product delivery lead, and I will talk on behalf of the entire DRP team. So the Roman chronograph data reduction pipeline development involves 20 active developers and consultants from 12 different institutions working from different time zones. We are organized in mostly bi-weekly meetings that are coordinated by the simulation and data processing working group, the CPP, co-led by Max Millard-Blanchard and Jason Wang. And this slide is presenting basically how we are kind of organized in that project. With the first of all, community participation program CPP, who is responsible for developing the core algorithm of the DRP. And that we delivered to the project science team, composed mostly of JPL and Goddard astronomers on the CGI team. Once the project science check and validate those algorithms, we will deliver the algorithm to the Chronograph Technology Center, or CTC, with the charge of developing some Docker images for the software, and then we'll deliver the software to the Science Support Center, SCC, that Jim just presented quite in detail. So the objectives of the DRP is to produce tool that processes Roman chronograph Excalibur level 1 frames and deliver L2 to L4 data products to the SSC for public archiving. Basically, our goal is to go from here to here, basically level 1 data to level 4 data. And I will describe a little bit what are those different levels in slide. And we want to do that for all CGI modes, the imaging mode with HLC or TTF5 mode, and also spectroscopy and polarimetry mode, and also the imaging mode with SPC. So those are the more thorough description of those data levels. We are starting with the level 0, which is a collection of packetized data. And then the L1 data are produced by the SSC. And those L1 data are 2 fits data that are combined and formatted with the engineering telemetry and appropriate metadata. Then those L1 data are taken as an input of the DRP. And the DRP requirements spans data from L2A to level at the level 2. We have the calibrated image with 2 sub-level, level 2A and level 2B. And that is the reason of those distinction, because between those 2 levels, it's mostly due to the consistency that we want to have for analog and photon counting data, which share the same level 2A, but not the same level 2B. Then the normalized image and astrometric calibration are produced at level 3. And finally, we have the final combined image from the entire observing sequence. And if applicable, this combined image will be PSF subtracted. And we have, last but not least, another level of data product that we call the tech demo analysis. This level, those products will be used to verify the TTR5 requirements, and this is not a requirement for the DRP. No formal archiving will happen for those data products at SSC. And speaking of requirements, here we have the official requirements for the DRP that I separated in different subcategories. First of all, the narrow field of view imaging data only, HSC, TTR5 requirements, as well as the milestones for the delivery of those requirements. Then we have the calibration reference data and also some requirements for the goal modes. Right, so now that we have introduced the objectives and requirements of the DRP, I'm going to talk about the architecture and implementation. The INT version of the data reduction pipeline was developed so that verification activity owners can process their L1 data and produce their own analog L1, L2A and L2B XCAM data for INT. And the DRP architecture is built on this INT legacy. And so we for the INT we stopped at the level 2B, and L1 to L2B wrapper was developed, and also their associated function to do that. This wrapper and associative function were hosted internally in the JPL GitHub repo, and we used Docker containers to implement that pipeline, and also test how it validates with respect to the requirements. We had the testing and validation framework in place. It's going to be also the same for the DRP, for the on-sky DRP, but I will not touch too much into that because Tim briefly presented that framework on his presentation on the DIB. So the on-sky DRP, that also is nicknamed Corgi, is built on this legacy, but presents some architecture differences. And for that reason, some work is needed to port the existing INT function and wrapper into the new architecture and build the associated Docker image. In addition, on top of that, we need to develop the L2 to L4 functions and wrapper, calibration function, and associating testing and validation framework. And some other small differences from INT is that, for example, for INT we were not able to acquire a proper master flat. And so we used a map of one, for example, or we didn't use a bad pixel map for the INT data. So there are a couple of differences that we need to account for and work on for this part of the data reduction pipeline. Right, so I would like to say a few words and make a distinction between the production and the standalone software. The standalone software, which is called Corgi, is the publicly accessible part of the pipeline. And this one will be here hosted in a public GitHub repo. And this pipeline is, the development of this pipeline is driven by the alignment and calibration and tech demo data requirements. This Corgi pipeline, along with the interface developed by CTC, will be converted into a Docker image. And this is this Docker image that will be implemented on the SSC, and will be implementing on the SSC, and that we will use for both test and execution of the production pipeline. As you can see from the color code, the DRP is a combination of Class C and Class D software, where we make a distinction between those two kinds of software. So the Class C software are critical to the operation of the instruments, and the Class D software is important to the success of the instrument, but is not required for the operation. Right, so a few words about the Corgi standalone software architecture. It is hosted on a public database, as I said, so accessible, currently in development right now. You will note the themed terminology. We have here an example processing flow for how this pipeline is going to work. So it will take the input data, and a worker will generate a recipe and execute this recipe. And based on the kind of input data that we will have as many recipes as we have different input data. And this worker will execute the steps that are needed to complete the reduction and produce the output data. Now, here's the interface for the data reduction production software. This interface is nicknamed the Watchdog, and it's going to be fed by L1 data and observation and calibration data. And basically, it will monitor for the arrival of L1 data. And once we have the requested L1 data, it will trigger the execution of Corgi. And Corgi will generate the stage product that will be managed then by the data management system. So here is a few more words on the data testing and validation framework that we have. So first of all, we will rely on unit tests for each of the step function that have been developed as part of the pipeline. And we have so possibility, even though we don't have those yet, to have some self-diagnostic tests. One other important component is this one is the end-to-end testing of the pipelines of both of the L1 to L4 wrapper of the pipeline, and also the generation for the calibration products as well. Those both unit tests and diagnostic tests and simulated tests will not like the second one last Friday. And we had a successful preliminary result from porting the pipeline to the new architecture. I'd like to thank our developer and stakeholder for the work on the pipeline so far, which has been relatively smooth. And we have a great deal of work ahead until launch, and also a very good start on that. Thank you. That's it.
Bruce McIntosh has his hand raised on the chat.
Bruce, do you want to go ahead and unmute and ask your question?
I think that's just a clicking in the wrong place trying to find the chat button. My apologies. I should let me say I admire whoever decided to name the data pipeline Corgi DP, though. I'm hoping for adorable logos going forward.
I guess you know.
Yes, I can guess.
Jason Wong.
Yes, but if there's not an adorable logo, I think I will be disappointed.